Hi, I'm Pierre for Morales and welcome back to this series of videos where together we learn how to code in Solidity. Today we're learning how to build a voting system. And voting is actually a very good example of how blockchain can be used and how smart contracts can be used in order to do so. It's very popular in the smart contract world, and there's a lot of examples that can be found, particularly in community-led projects that allow you to just vote if you're holding a particular token, for example. Vote on what? Well, it can be on the development of a particular project, and what the dev team should do, or simply just what direction a project can take. But it can go, in fact, to almost anything else that we'd like, including some are working very seriously on smart contracts and, in general, tokens that could allow us to vote, including national voting and how it can be implemented there. But we're going to be looking at a bit of course, more simple example, but a fully functioning example that could work that could be applied to any application. But we're going to make sure that it basically follows the 6 most important concepts that are needed for a voting system to work. And the first one is that it has to be a secret ballot, which means that no one should be able to revert back to you and know, well, your name, your gender, and so on from the votes that you chose. And in order to do this, actually, we're going to be using the Ethereum address, which really is the only identifier that will be there for you. Then we're going to also make sure that one address can have one vote, not more, just one per person. We also have to make sure that voters are eligible for that. So actually, the way we're going to do it is that whoever deploys the smart contract and runs it is also responsible for setting the addresses of people that are allowed to vote. Then, of course, transparency. Well, all of the rules of the vote should be transparent. What I mean by that is that the rules for the voting system have to be clear, understood by everyone, and this is why this kind of stuff is done on the blockchain. And if you have it as an open project, even better, anyone can audit it, basically. Then, of course, we need the votes to be accurately recorded and counted for, so that there is no mistake there. And finally, we need to make sure that it is reliable and that no fraud is possible through this voting system. And we're going to do all of this in Solidity. It's going to be quite fun, and I think we can go straight away and start with the code. So you see I created a new file called 11 voting. It's the 11th coding exercise that we're doing together, and I call it voting because obviously we're doing our voting system. So as usual, what we're going to do is we're going to start by simply saying what version of Solidity, we'll be working with, which should be right, and okay. And we're going to have our contract that we're going to call ballot. Awesome. So as usual, our contract is going to be separated with just 3 sections. So we're going to have our variable declarations, so variables at the top. Then we're going to have whatever modifiers we may have. We're also actually going to add in here our events. And finally, our functions. And let's maybe just add a space here to make it look neat. Awesome. And so what are we going to do? Well, first off, let's go and declare our variables. The variables that we're going to use are, first off, a struct. We're actually going to use 2 structs here. The first one is going to be a vote. And the vote basically has to be it has to take an address that is the address of the voter. So we're going to call it voter address. And finally, we also want a bool that would be, bool that will be the choice of that person. So basically, depending on whatever vote there will be, what they will be saying true or false, I want it, right? So it's a bool. Then we're also going to create a new struct, and this one will be voter. And it's going to keep just a string that will be the name of the voter. Can be anything, doesn't have to be, of course, a first and last name, right? And we're also going to keep a bool that will be his vote, whether he voted or not. Sorry, voted. Here we go. Whether he voted or not. It doesn't mean that we know what he voted. We just know that he voted or not. Awesome. And now we're going to need quite a few integers and other addresses and things that we're going to be keeping. So first off, we need a uint that we're going to make private. And this one we're going to call count result. This one is going to be here to count the votes as they're coming in, but we want to keep it private because we can only see the vote result at the end. And at the end, basically, what we're going to be doing is when the vote is finished, whatever value is inside of count result that is a private integer, we're going to input it into final result, which is a public uint. And this way, this is how we're going to communicate the results to everyone that voted or just observes. Now we also need to keep a count. We're going to keep the count of all of the voters. Total voter equals 0. And we're also going to keep a count of total votes 0. So basically, that's the total amount of voters, and this is the total amount of votes. Yeah? And we're just going to track these. And I mean, in theory, they should be equal. Okay, so now we also need to keep an address, and this address we're going to make it public, and this will be the address of, so the official address of this ballot, and we're going to call it ballot official address. And we're also going to keep a string that we're going to call public, and this will be the ballot official name. And again, another string that is also going to be public. And this will be the actual proposal of what this, what we want to achieve based on this, this vote. All right. Now, we also need some mappings. And these mappings will keep them simply to be able to refer and find our votes. And also so that we can simply keep a list of our voters. And they're going to be using different values. So the mapping is going to be a mapping of uints to a vote, right? And we're going to call it private, and we're going to call it votes. Awesome. Now we're going to create our second mapping that is going to take, it's going to be a mapping of addresses to voters. And we're going to make this a public one, and we're going to call it voter registry. Sorry, register, better. Yes. Okay, so now the next thing we're going to do is we're going to build an enum, and this one is going to be basically keeping the state of our contract, of our ballot, just tracking where we are in it. And so to do this, it's going to have three states. It's going to have the state created, the state voting, that will simply show that people are voting at this moment, and ended, that will just represent the fact that the contract is finished. And with this enum, we're just going to declare one new public state that we're going to call state. And this is the variable that we're going to be using in order to track this state throughout the voting. All right. And for now, that's it. When it comes to the functions that we're going to be creating, I think we can take a look at them now. So obviously, the first one that we're going to be doing is the constructor. Right? Okay. And then we're going to be using a function that basically will allow the person that created the function to simply add voters. And that's what it's going to be called. It's going to be function add voter. Okay. Then we're going to create a new function, but once, the status, the contract starts in the status created. And one sec, I just need to change here. Okay. So the contract starts with the state created. And what we need to do is once, so during this state, the creator of this contract can just add all of the voters. And once he's done with that, then he can start the vote. And this is the function we're going to do here. It's called start vote. Simple enough. And then we're going to do a function that will allow users to vote. So we're going to call it function doVote. Perfect. And then the last one, once everyone has voted, once whoever is actually running this this contract decides to, then we're going to basically allow him to end the vote. And once the moment the vote ended, we change the state of it to ended. We count all of the results and display them by adding them inside of our final result in here, because it is our public variable here. And then we'll just use one of the events that we will create eventually in order to just send the message to the blockchain that, you know, it's done. The vote is finished. And what is the result? So that's it for today's video. In the next one, we're basically going to develop the rest of these, well, all of the functions. We're also going to create our events and modifiers, and we're going to test this. But for this video today, this is it. I am Pierre for Morales. Thank you very much for watching. I'll talk to you in the next video, and until then, take care.